Hey, Peter, ready to do P2 when you're ready.
Yeah, I'll do a presentation on that too, probably 5th of August if everything goes well. So get the boards back and everything, and Ken even suggested just doing some, even a little bit on the layouts, how I do layouts, etc., and component choices and so on.
I've got North America description. Ready to go. Hey, you go.
Very good.
No problems, mate.
Yeah, no, that'll be good. Yeah, so we'll be in touch.
All right.
Thanks, mate.
Okay, everybody, I'm going to go ahead and do some muting. And if you want to say anything, just unmute yourself and then remute.
It's easy. You just have to press the space bar when you want to talk.
Oh, perfect. Okay, yeah, use space bar as a shortcut. Well, 2 p.m. Pacific time. Eric, shall we get started?
Sure, we can start. I mean,
okay.
The first little part isn't going to be terribly.
I've got a little intro before we get rolling. Some things that have come up just during the week that I'll go through very quickly. For those who are first time here, welcome to the Propeller 2 live forum. We call this the early adopter series, and anyone can do a presentation on anything of interest. We're seeing a lot of tools and hopefully some applications soon. Today is Canada Day. Bob and Eric, we have at least 2 Canadians on board. Thumbs up out there, yay! So it's a day off for them. Thanks for joining us from Canada. It is summer as well, so we don't forget. Here's a picture of Whit, the robotic reverend at Old Faithful a few years ago, wearing a Propeller shirt. About these displays, they're coming. They should be in stock here in like a week. They're very nice. You're going to provide your own power supply, 5 volts, $40, 180 of them coming. I was asked about the P2 evaluation board, Rev C, and we had some issues with getting circuit boards delivered, and then the factory identified some QA problems, so they've since fixed that. We got the boards, and then we're waiting to build them, but some other things went out of stock while we're trying to get these on the pick and place line. Ran out of flip modules, so those took precedent, and now these boards go on next week. So by mid-July, they will definitely be shipping out. And as you can see, you can get them. They're actually $15 off for 4th of July. We also ran out of the accessory kits. Those are going to have a longer lead time because, well, when engineers get the opportunity to change things, you run out of stock. And the Gortzel board was up for revision by chip. So that's a little bit of a delay. On the P2 chips, we have 2,500. The big news here is that we have placed our first production order. It's not a big order, but we did place it, and those chips arrive in October. So we're just going to regularly get deliveries and try to have what we need. I talked to W9GFO yesterday and said, we're making more boards. Do you want to make more enclosures? And he said he was in the middle of a massive shop renovation, but he wanted to stop and plug in the laser cutter and make another 100. So he's doing that, and we will have another 100 of those enclosures if you want them. And also, we've had a lot of GitHub uploads. Johnny Mac has put the majority of things here. John, what is here? Got to find that mute button. Okay. Oh, he's having trouble. Okay, I'll unmute you. Let's try this again. John is stuck on permanent mute. That is not the right place for him at all, because he has a... All right, we'll see if he's going to go out and come back in, sounds like. But in the meantime, there are at least 5 or 6 objects here in GitHub. display, looks like maybe IO expander, some LCD stuff, and then we've had a lot additions by Ale, some sound type objects. And just so you know where to get them, you can go here to GitHub. Now, I don't want to spend a lot of time on this, but people have had trouble figuring out how to download, because when you click on an object, you get a bunch of HTML gobbledygook. What I've been doing is going to click on Propeller, and then under the green code button, there's this download zip. I think that's the way to get everything at once and just replace what you have or manage it carefully. So next week, James Casca is talking. He's the creator of Virtual Breadboard. He's online watching right now. So that's next Wednesday. And also Eric has done so many wonderful things for us that we need to support him. So go over to Patreon and drop some money towards Eric. It's never going to be enough. I know from developing software, watching software developers, no matter what we do is not enough, and he's contributed so much. But I'll paste that link into the chat.
Thanks, Ken.
Yeah, you're welcome. I'm never afraid to ask for money, especially for others. So we'll start that process for sure. So Eric, I'm ready to pass to you.
Okay, great. I'll hit the share screen. Okay. Everyone see?
Dai, sì, infatti perché qua hanno già cominciato. Dai, buona serata, buonanotte e ci sentiamo.
Hello?
Okay, I'll go find that one.
Someone from Europe, I'm guessing.
Dai, sì, vediamo come metterla bene.
Can everyone see the
Ciao, Mauro.
desktop okay? Is it?
Figurati, ciao.
So what I'm going to do, his mute button has disappeared, so I'm going to mute all and then
Okay.
unmute you. Okay, and then Eric, if unmuted you, you could say something. Hopefully you've come back.
Hello? Okay.
Yeah, great. Now we're
Okay.
rolling.
All right, great. So I was going to talk today mainly about the FastSpin compiler, but it's part of FlexGUI, and I just wanted to sort of discuss what the difference is between FlexGUI and FastSpin. FlexGUI is just a really simple GUI, like IDE interface that runs the compiler in the background. So it has basic editing, you can run stuff from it. It's nothing particularly special about FlexGUI. It's just something to get you going quickly. I know that Ray had made a tool called Spin Edit, which I think is probably nicer, although it's Windows only. Some people have used Visual Studio Code. You can use whatever editor or IDE you're comfortable with. The FastSpin compiler itself, you can do pretty much everything on the command line, or you can, because of that, you can wire it up to your IDE of choice. But FlexGUI is there for, beginners, or if you just don't want to have to be bothered hooking it up to something else. There's something you can get started with quickly. So the magic is all in FastSpin. So why would you want to use FastSpin? Well, first of all, it's multi-language. So it supports C, Basic, Spin 1, Spin 2, and of course PASM, the assembly language. We definitely want Spin 2 because that's the official P2 language. There's going to be lots of objects written in it. I know that John McPhailin has already contributed some nice objects, and I think most of those probably work with FastSpin, at least the ones I've tried have. And if any of them don't, I'll fix FastSpin. It's still a work in progress, but I definitely want the official objects to work. Spin 1 is the version of Spin that FastSpin was originally designed for, and I kept it because it'll help you port your code from the P1 to the P2. So you can take if it's a pure Spin object with no assembly, and it should just compile and work on the P2. Of course, there's some hardware differences and timing differences and things like that. So, you know, it's never going to be 100%, but you can get a lot of the way there. And C and BASIC are pretty widely used. So you may be able to get third-party code from the internet or what have you. So it's nice to be able to use all these languages together in one tool. And I'll show later how they can call between each other. FastSpin supports both the P1 and the P2. So you can make the same program run on both if it doesn't have any hardware specific things. Obviously, assembly language code would have to be rewritten. There is a preprocessor, so you can use #ifdef to, you know, put sections of code that are P1 specific or P2 specific under the ifdef. So that's one way to go too. Now, obviously, FastSpin's a native compiler, so it's producing machine code, which tends to be pretty big compared to the bytecode that ChipSpin produces. So on the P1, it gets pretty tight, but on P2, we have a lot more room, a lot more RAM, so it's not nearly as bad. And the other reason to use FastSpin is that it's cross-platform. It works on Windows, Mac, Linux, Raspberry Pi. I haven't tried it on other platforms, but it's pretty portable code. And FlexGUI comes with Windows and Mac binaries. FastSpin's got some useful features like the built-in preprocessor. It can produce fairly nice listing files. I'll try to show that later when we get to it. And of course, the name FastSpin, it's designed for performance. It produces native code, so it's a native code compiler. So the code should run pretty quickly. So if you need speed, you can take your Spin2 bytecode, Spin2 code, get it debugged and working in Chip's environment, which is, I think, going to be a very nice environment. But then if you need that little extra bit of code but don't want to have to rewrite an assembler, you can compile it with FastSpin. It's got a bunch of optimizations, which I'll show soon, but things like, A++ or A plus equals 1 or A equals A plus 1, all should produce the same code. So you write your code the way you want to and let the compiler worry about optimizing it and making it run fast. So here's an example, just a small example of the things it can do. A little function to add an array of integers. So you're taking n integers, 2 different pointers. This is C, of course, but we could do the same thing in any of the languages. So it just loops through, and A of I is set equal to A of I plus B of I. So this is with the O2 option, FastSpin's highest optimization level. It produces this code. So it starts out by looking at argument 1, that's the n, compares it to 0. If it's less than 0, it jumps right to the n and aborts, because this loop isn't going to do anything if n is less than or equal to 0. Otherwise, it does this copy, which isn't really necessary. I need to fix that. And then it repeats that many times. So it's going to repeat n times, because it's noticed that I never gets changed inside the loop, so it doesn't need to. You can just change that loop directly into a repeat statement. Reads A, reads B. So A sub I and B sub I get read in, added together, written back to A, and then it increments the pointers. So you notice that it's changed these array indexes into pointers automatically for you. So you don't have to worry about, are you writing the most efficient code? Now, this is kind of this is the kind of thing that it's been specifically designed to do. In not every case is it going to optimize this well, but so it's not quite a production quality like GCC or LLVM, but it can do some basic kinds of things, some fairly, useful optimizations for you, and generate code that's going to be decent. I try to make it natural code output, the kind of thing that you would write yourself as an assembly language programmer. Again, this is with the highest optimization level. At 01, it's probably not going to do some of these things, like it might still do the array lookups instead of having them as pointers. So, FastSpin's great. It, it does everything. Why wouldn't you use it? Well, it's not perfect. It's not completely Spin2 compatible yet. I'm still working on that. Actually fixed a whole bunch of things this week to get some chips code compiling. The C compiler isn't completely standard compliant either. The libraries are, it does most of what's in the C99 standard, but the libraries aren't complete. There's no linker, which makes porting code a little, big projects are a little bit trickier to port because you have to compile the whole program and put all the C files on the command line. The C compiler is kind of lax about the order of declarations. So just like Spin, it doesn't really care what order you declare functions in, which is not standard in C. Normally in C, you have to declare things in the order so that the compiler sees the declaration before the use. And as I mentioned before, the code is machine code. It's actual binary instructions rather than byte code. So it needs about twice as much memory as the Spin2 bytecode compiler would. On P1, that's a big difference. On P2, depending on your application, it may or may not be an issue. So this is probably, I was going to fire up FlexGUI, but this might be a good place to ask questions if there's anything.
Eric, on the tab on FlexGUI that allows you to choose optimization, there's a normal optimization and then a full optimization. What's the difference between those two?
Okay, so the full optimization is the O2, and that adds some extra things like turning these array references into pointers. So this is what you get with full optimization. With normal optimization, there'd probably be a little bit of arithmetic. It would add the I to the base of the array A and do the long load.
All right, is fast cache only included in full optimization?
No, that's included in all of them now. It used to be only in the full.
Okay.
It's in all of them now. Yeah, I forgot to mention fast cache. That's another interesting optimization. Small loops will get loaded into, on P2, we use the LUT to hold code, so we can load a small loop into the LUT and run it from there. I think I compiled this code for COG, so it didn't show the fast cache. That would have been another layer of stuff. Okay, well, if you've got FlexGUI, I'm just gonna fire up. So I'm on Linux, so it'll be slightly different on Windows, but you'll click on the FlexGUI.exe, and you'll get a window something like this. I don't know how well you can see the menus. Unfortunately, I don't know how to make the menu font bigger. But there's sort of the standard file, edit, options. Under options, there's an editor options, and that has stuff like the tab stops you want for your source code. You can change the font you're using, which I've already done actually to make it a little bigger. And what else can you do? There's syntax highlighting, which we'll look at. Actually, why don't I open a file? I'm going to open chips, VGA text demo to start with. So this is what some spin code would look like in FlexGUI. It's got some syntax highlighting, like strings get highlighted red, numbers get highlighted. My font's missing the underscore. I'm going to change that. Let's see, Courier. There we go. They're back. Okay. So running stuff is pretty easy. There's a big button that says compile and run on P2. So you load your, I'll get rid of this window. I don't need this anymore either. So you load up the source code that you want to compile, and you click compile and run on P2. Down here, it outputs the results of the compilation, and then it opens a terminal window automatically. And I've got a video capture card, so this is what you would see on the monitor. So this is Chip's VGA text displaying on VGA. So that worked really well. Now, this is slightly annoying. You have to remember to close the terminal window. And if I don't do that, I'll get an error. I haven't figured out how to do that automatically yet. Okay. So to get started, I'll close this. So the easiest way to get started in FlexGUI, like I say, is either to load something already, like I loaded Chip's program, or you can just do some basic program like print hello world. If I click on compile and run now, it's going to ask me to save it. So I'll enter a name, hello.basic. And it pops open the window, and there it says hello world. So really easy, basic is probably the easiest language to get started with. If you wanted to loop, you do something like for I into 10, print hello world I, next I, compile and run. And there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So nice and simple. I'll just go over some of the menus a little bit. Like I said, there's the options. You can change the optimization. There's commands. These are basically what's attached to the buttons, but you can customize them. This is probably hard to read on Zoom, but there's a whole bunch of options you can. So you can change the command lines. You could use a different. It doesn't have to use FastSpin. That's just a FlexGUI thing, but normally you would want to. You can change the baud rate. The default is 230,000. And you can explicitly set which port you want if you've got multiple devices hooked up. On P2, there's some special features, like you can actually enter TACOS. I'm not very good at fourth, but you can enter fourth code there. And so if you wanted to do some debugging, I think, probably Minicom or something might be a better terminal, but to quickly get into the ROM, you can do it from FlexGUI. And there's a help menu here. So you can get help on things like basic. There's a fairly big manual for the Flex Basic. The C and Spin language are not so comprehensive. They sort of rely on you knowing C or Spin already. And there's a little bit of general compiler features, about how the languages work, how you can declare objects. It's probably worth. We could always use more documentation. This is definitely a work in progress. but it does talk about some of the optimizations and what level they're in, O1 or O2, and so on. So the help menu is pretty useful, I think, but it needs work to get even more useful. Okay, so that was a hello world in BASIC. If we wanted to do hello world in Spin, this will be our first multi-language. I'm actually going to do that by using, I'm going to cheat and use the C library. So I've declared the object C to be libc.a. That's the C library. And then I can make calls into that library, like c.printf. Oh, I need to make this a string. And then I'll put a carriage return on the end. So I'll make this hello.spin. And there we go, from spin. So again, it's designed to get you going fairly quickly. You know, you enter your code, compile and run, and your terminal's right there. And I use the terminal a lot. Like if I'm debugging something, you know, even if I've got something hooked up to pins, it's nice to be able to print some serial stuff. And John McPherson's got some nice serial objects for Spin. You can use those. You can use the C objects. If you're doing BASIC, you can just use print. Easy to get going. Any questions so far?
Eric, I've been using F10 to do the compile and load.
Mm-hmm.
Does it save when you do a compile, when you just push F10?
Yes. Yeah, anytime you do the compile and run, it'll save before it compiles. Okay, so I'm going to go into the samples directory now, and samples multi-language is where the demos I was going to look at are. Now I'm going to start with a pure PASM program. So simple example of PASM, the blink pin 57. So this illustrates the preprocessor. We can do a sanity check. There's a built-in symbol, underscore, underscore, P2, underscore, underscore. And if that's not defined, we say error, this demo's for the P2 only. So if you tried to compile this on P1, it would fail. Another useful thing about the preprocessor is that you can define a symbol like, say, debug pin. I'm going to turn that on. And if it's defined, you see later on here, if def debug pin, drive low debug pin. So it'll take whatever the symbol's defined to, in this case, the string #56, and replace it in here. So this is just like I typed drive long #56. And then, you know, this is just an LED blinker, so we're going to toggle, wait for a delay, and jump back to the loop. So if you compile and run this, there's no serial output, so I'm just going to close the window. You should see pin 56, our debug pin, will be lit up, and 57 will be blinking. Now, I just was going to illustrate some FastSpin features here. If we forget the £, it's not going to work right. And you'll see here, I don't know how easy this color is to see, but there's a warning, jump to loop without £. So in fact, we didn't want, we forgot the pound sign. It's going to tell us about it. It is only a warning because this is assembly language, so you can shoot yourself in the foot if you want. But most of the time, if you jump to an instruction, which is what's following loop, you want the pound sign there. Now, in some cases, you might want an indirect jump, though. Like here, we've got an indirect label and a long loop. So we're doing a jump through the label indirectly. It's gonna be happy about that because it sees this is data. So you probably did really want to leave off the pound sign. There's also warnings for things like compares when you forget to set flags, or if you use small constants without the pound sign. They're just little quality of life things to try to make catching bugs a little bit easier, and I'll keep trying to do that. Okay, so I'll just talk a little bit about spin programming. So the default for spin programming in FastSpin is spin 1. And like I said, you can use that on P2 as long as the assembly is the P2 ASM and not P1 ASM. And that'll be useful for as a stepping stone for porting your code from P1 to P2. I think a lot of people have been working that way. They'll take their P1 code, get it working in FastSpin, and then clean it up and make it Spin 2 compatible and get it working in CHIP's compiler. If the file extension is actually explicitly Spin 2, then it enters a Spin 2 compatible mode, which is slightly different from Spin 1. Some of the keywords are a little bit different. Some operators are interpreted a little bit differently. But the difference in FastSpin, the difference between .spin and .spin 2 really is the language and not the processor. You can have P2 code in a .spin file. You can compile a .spin 2 file on P1. And there's a big overlap between the FastSpin dialects of Spin 1 and Spin 2. Like you can use a lot of Spin 2 features in Spin 1 and vice versa. Okay, so we were looking at the pure PASM. I guess I got ahead of myself a little bit, but if we look at pure PASM.c, normally this kind of pure assembly code we write in a .spin 2 file, but we can also do it in C. So this starts off the same way, except we're using C comments instead of, well, actually C++ comments, but FastSpin C likes that. And when you get down here, instead of a dat block, well, there's no con block, so we do everything with pound define. And instead of dat, we have underscore PASM. But otherwise, the code is just the same. And it works just the same, too. If you compile and run, you'll get the same blinking pin. This, obviously, if you're writing your assembly code, you might as well write it in Spin 2, but there might be cases where you have an assembly program you want to launch in another cog, and you're using it from C. In that case, it might be more convenient to put this block in your C code at the start. Any questions so far?
Eric, Ken here. I was curious what the extent is of the basic that you were showing. What can you do that is P2 specific?
It's pretty much the same as the other Spin and C. It's got it's got commands for smart pins. It's got output and input.
Video?
It's not built in, but you can use a video object, and we'll be actually seeing that.
Awesome. Okay, thanks.
So I think a lot of people are interested in C, so I'll just talk a little bit about the C language support that FastSpin has. So most of C99 is implemented. That's the standard from 1999. It's kind of old now, but it's also the most widely used version of C. There are a few C++ features that are extensions. It does have simple classes, so you can create objects that have methods. There's no inheritance, but basically because I wanted to be able to use spin objects in C, I had to implement classes anyway. That's what a spin object is. And there's a few other C++ features, reference, variables passed by reference, default parameter values. And I'm gradually hoping to increase the C++ support a little bit, although it's never going to be a full C++ compiler. But there's still a lot to do too. Mostly like the libraries need work. Roy's been doing a great job porting the simple tools libraries. And so eventually, hopefully we'll have a lot of that. There's still some standard libraries that need porting. And it'd be nice to have 64-bit integers. That's part of the standard, but that we haven't implemented yet. And real double precision floating point. Right now, all we have are single precision, 32-bit floating point.
Eric, can I ask a question here?
Sure.
One of the interesting features on the P2 is the 64-bit getCT.
Yes.
If you had 64-bit integers in this C language, would you be able to read all 64 bits of that getCT register?
Sure. Yep. And in fact, you can now, but it returns it as a structure with two elements, the high and the low. But once 64-bit integers are working, it'll just return a 64-bit integer.
Thank you.
So I guess we might as well go into the demo. There's a substantial C program here. Let me close these. Control W is the shortcut for closing a window in FlexGUI. So let's open the Mandelbrot.c. So this is nice, pretty graphics, which Ken has already showed off. Let's just compile and run it, and we can see what it looks like. There's my video capture card. Takes a little while for the capture card to clue in. So there it is drawing. Wasn't terribly swift, but that's because it was only using one cog. So if we enter 6 cogs, it goes a lot faster. So let's see. The video object here is in the video folder, and that's Roger Lowe's P2 video driver, VGA DVI driver, which is written in Spin, as you can see here. And it's got, you know, your usual Spin kind of defines variables. He's got nice clean code. It's well commented. There's his init display routine method. And somewhere down here is all of his PASM. It's worth taking a look at it anyway. It's a very, very flexible, yeah, there's the PASM. It's a very flexible driver. It can do all kinds of interesting things like having regions of text overlays, a mouse, different types of, you know, it'll support 8-bit per pixel, 16, 32. It's got everything in it pretty much. And as I say, to use it, you just say in C, you say struct using. I had to put 2 underscores there because it's a non-standard keyword. And then the video / p2 video driver dot spin2. And then the name of the variable vid. And then down here, this is various helper functions I have. The actual video setup routine is near the end. There we go. So it calls the object just the way you would in Spin. It says vid.initDisplay. Oh my. I was thinking so much in Spin, I wrote ampersands, which actually works. FastSpin will take @ sign in place of ampersand, but I should have written this in proper C, so my apologies. Like I say, that's an extension that FastSpin will take an @ sign instead of an ampersand. So vid.initDisplay, vid.initRegin, so it sets up a region with RGBI pixels, 480 lines. I forget what these other parameters are, and uses the frame buffer, and then it enables it. So pretty simple to use. It looks basically just like Spin. The only tricky part is you have to use the __ using. And the rest of this is just plain C code. I've got a little bit of inline assembly, I think, here. Yeah. Simple routine to square A. I used assembly, took the absolute value, used QMO, get QX, and then returned the value. This may not be exactly what you see. I think I had a bug where I had this the wrong way around. I had fixed point -32, so it wasn't working with anything other than 16. And to run the multiple cogs, I set up the number of CPUs. And for each CPU, I use the cog start function. That's not standard C, but it's something that we defined in Propeller 2.h as a method. It's similar to what we had in Propeller 1, a method to start a new function in another cog. And it takes the function you're going to call, in this case, the function renderMandel, a single parameter, in this case, the integer I, a pointer to a stack that cog's going to use, and the size of the stack. And this same kind of code should also work in Catalina or in RISC-V P2 or any of the other C compilers for the P2, as long as they use the Propeller 2.h that we had hashed out on the forums. And then we can use the serial for it and enter the number of cogs that we want to render with. And you can kind of see that it's alternating lines. So if you render with 3 cogs, each cog does every 3rd line. Really simple way of splitting up the work. Probably a good place for questions if anyone's got some.
Hi, Eric. Do you have an example you could show us where you're maybe calling a function in a different language and getting a result?
Yeah, that's a good question. Actually, none of these, but it would be just a matter of, assigning it to a variable. You'd say something like integer x equals vid.init. If initDisplay did return a value, it may actually, I haven't looked, but it may return a, true false, whether it succeeded or not. It's just a matter of assigning the result to a variable. Now, if it's returning multiple values, C doesn't support that natively. So that could get a little bit tricky. It's only going to get the first value that was returned. And there may be some way to fake that, but that's getting into some magic there. But single return values, which is the normal normal function return is straightforward.
Thanks.
Okay. So that's how to call some spin from C. I'm going to go on and do a more complicated example. And that's this turtle_demo.basic, which is also in the multi-language directory. So this one is a basic program, and I'll just sort of go over again the basic, Flex basic. It's very simple syntax. It's got built-in I/O, floating point, some other nice features. So, if you need to do floating point math, it's easier to do it in basic than in spin. It's mostly MS Basic compatible rather than being compatible with the Prop Basic, with the goal that we could port code over from other platforms. So even some really old school code with line numbers works. And there's a demo, one of the samples is a lunar lander program that you can compile and run from, back in the 70s, where you'd have to enter how much fuel your lunar lander is burning. Like spin, the basic can have PASM blocks, and like C, you can put inline assembly. I was going to open up the LED interactive.basic, but I'm not going to. Actually, I guess we can open it. Simple demonstration of running PASM code from a basic program. So ASM shared is the way you make a DAT block in basic. It creates global data that's shared by all the instances of an object. So if you have 4 objects using this LED interactive.basic, they'll all use the same copy of this ASM shared. This one, oh, actually, yeah, okay, I remember this program. This creates just a simple server that runs in another cog that can light up the 4 pins, 56, 57, 58, and 59. So we start by driving all those high, which turns them off on the P2 eval board. Read from pointer A, get the current value of the flags, and them, flip them because the LEDs are active low. Shift them up and put them in the out B register, and then jump back. That's a really dumb little program. And we talk to it by setting up a variable. And we run the PASM in another cog. And this is just like cog start. So CPU is the basic name for cog init, sorry. And it works the same way. You pass it a pointer to the code you want to run and a parameter, in this case, a pointer to the flag variable. And then we loop and we keep changing the flag variable. And the PASM code is reloading it every time through its loop, so it's constantly updating. So if you run this on your P2, oh, this is weird, what happened? Okay, demoitis. Let me just reset my board. Oh, okay, yep, this is where I've got another window open. I forgot to close a terminal window from one of my previous runs. And you can see here it's printing out the ROM as the loader is trying to load something, it keeps getting responses in the wrong window. So let's try that again. Here we go. So it started the PASM code. It says to enter a number. And if I enter 1, it'll light up pin 56. If I enter 2, it'll enter 57. 4 will be 58. 8 will be 59. And we can light them all up by entering 15. So the takeaway from this part is just that it's really easy. You know, you can use the basic in a very similar way to spin. You got something like a DAT block that has your code, and then you can start it up with this CPU function. You can actually run basic functions in another cog too. It doesn't have to be assembly code. And again, it works just the way spin's coginit or cognew works. Actually, I guess it's more like cognew because you're not telling it an explicit cog number in this case. Yeah, we still got a little bit of time. So any questions on this part, and then we can go into the last demo.
Eric, just a general question. Are you going to put these slides out on GitHub or somewhere?
I could put the slides up. I hadn't thought about that. This code is all in GitHub now. But yeah, I can upload the slides, sure. Or maybe we can put them on the forums. I don't know what, Ken, do you have a place?
Yeah, I usually put them with your YouTube link, which is on that forum thread.
Okay, I can do that.
Send them to me and I'll post them.
Sure.
This is Mike. I've been using this for a couple of months now on Prop 2 stuff, and I'm very impressed, Eric.
Thank you.
So keep up the good work. Thank you.
Thank you.
I'm also curious among the users which languages you are using with FlexGUI. So maybe you can just tell us informally, there's a reaction button on the bottom of your Zoom window. So if you're using Spin 1 or Spin 2, do a thumbs up. Taking an informal poll here. Okay. And if you're using C, do a thumbs up. Okay, quite a bit more C. How about any basic users?
I know Jeff's using BASIC. He's given me some really good feedback.
Yeah, there are a couple basic. Okay, so C is the big reason too.
Not really. I wasn't fast enough to mark spin also.
Well, it's nice to be able to use the spin and C together, and actually,
Definitely.
yeah. And you can use BASIC too. The last demo I was going to do here was this turtle graphics demo, which is called turtle_demo.basic, and that uses the same video object, Roger Lowe's video code in the P2 driver. But it also uses a C turtle drawing code that I downloaded from the web. Simple array-based turtle graphics engine in C. Originally, it was designed to export to BMP files, but I modified it so it could write directly to a frame buffer, which was a very small modification I had to make. And in BASIC, you import an object as a dimension variable as a class using, and then the string that says the file that you want to import these things from. So dim_vid as class means that we're doing the same thing we did in the C demo. All of the spin video methods will be methods of this vid class. For the turtle demo, I've called the variable t. So all of these, I'll just click to get back to all of these functions that like turtle RGB to pixel are going to be accessible as t.turtle RGB to pixel or t.turtle init. So we can see, this is all of the video setup stuff, set up the video, set up the baud rate. Now here's something a little bit interesting. The Load P2 program that FlexGUI uses has a built-in file server. So you can mount the PC's file system on the P2 and write to it directly. So this demo will illustrate that. When we take a screenshot, it'll be saved on the PC. So using the turtle object that we set up before, we just say t.turtle init and then do some stuff like forward, turn left, forward, turn left, forward, draw the turtle. And if we compile and run this, okay, so it's telling us that it's saving the screenshot. And my capture card is slow, but here's what the capture card sees. And we probably have in the samples directory in multi-language, there should be a p2screen.bmp. And that's where we've done a save bmp/host/p2 screen. And remember, we mounted the host using the file server. We could have saved it on an SD card. Instead, we could have mounted it as VFS Open SD card instead. But not everyone has an SD card, so I chose to do it there. And if we open that p2screen.bmp, you see there's it's only 320 by 240. It's scaled up by the video driver, so that's why it looked a lot bigger in the screen capture. But this is kind of convenient for dumping data quickly to your PC. And that's, again, accessible easily from C or BASIC. And actually, it wouldn't be too hard to use it from Spin either. You could use the C library like we did in the Hello World. Yeah. And again, the BASIC is really a simple language for prototyping. So if we wanted to make that a complete square, we just have to do one more, turn left again. And let's go 75 this time. We'll go a bit further. Compile and run. Oh, okay. I again forgot to close my terminal window. So that's a pain, and I wish there was some simple way in this graphics toolkit to find out if there's a window open. If there's any Tickle TK experts out there, please let me know. But there we go. This time we closed the square off. And obviously, you could put for loops around this, or this would be kind of fun for in an educational setting. You could have people program their graphics just like, or for that matter, you could maybe hook up a real robot and, instead of using the Turtle graphics package, use a robot package of some sort and have it drive a real robot. Okay, so that's pretty much everything I've got, I think.
Eric, in terms of finding a bug, do we submit that directly to you?
Sure. Definitely don't bother Parallax. So you can submit it to me, you can email it to me, you can post on the forums, or you can post a bug report on GitHub. Probably the bug report on GitHub is maybe the best way, because then it's permanently recorded. But forums are good too. I tend to notice those bug reports there. There's certainly plenty of bugs still in FastSpin. It's, I'm just one guy. So all the feedback I can get is really helpful. Obviously, I don't think of all the different ways that people use Spin or C. I tend to have one way of doing things, and that's pretty well tested, but things that aren't that way might not be as well hashed out. There's very frequent releases. I'll probably have another release of FlexGUI and FastSpin this weekend that fixes a bunch more bugs that people have found since last weekend. Even just doing this demo, when I compiled some of Chip's things, his parser.spin2 showed up a lot of bugs in my spin2 implementation. So I've fixed most of those now. And I'll be sending out another version.
Eric, one of the major wins in my view here too is the Mac ability. This runs on a Mac.
Yep, it runs on the Mac, Windows, and Linux. Well, I'm running on Linux now. This is what you're seeing on your screen. The Mac version will look a little bit different, of course. I mean, some of these widgets will look a little different, but I think people are using it successfully on the Mac.
One question I have is, could you tell me more about that virtual file system you had there? That sounds very interesting.
Yeah, so the virtual file system, this VFS Open Host, it uses the Plan 9 protocol to communicate. So basically, it's using the serial. So when we run this, while it's saving the screenshot, it's communicating to this serial program, but it first sends a special escape code that says I'm sending file data. So the program interprets that and says, okay, instead of printing this on the screen, I'm gonna do some file operations. So, you know, opening a file.
And that is built into the P2 loader?
Yes, it's built into Load P2.
Cool.
And there are some more demos for that. Let's see, those are not in the multi-language, but in the file server directory. There's a few different, there's a basic program, a spin program, and some C programs. So the spin program does a directory listing of the current directory. Everything happens in the directory that's the current when the program is run. So if we go back here and open a file, you can see what files are in this directory, and they're the same ones that it just listed. Oh, no, actually it's got some others. Oh, that's because I've filtered. Yeah. Oh, that reminds me, I haven't shown you the listing files. So under the file option, there's a listing file. And this shows you the generated code from these programs. So you can see exactly what the compiler is doing and where it's putting everything in memory. They always start with a bunch of startup stuff where it has to re-init itself and jump to hub mode. But eventually you get down to where it's doing this is all set up. Here's the pub demo, serial.start. So it loads the values into argument registers and calls the smart serial start function. So you can sort of figure out how things work. And this is kind of useful, like even just for pure PASM programs. I should have shown that when I was demoing the pure PASM. And it should update my list. Oh, I don't have the listing. There we go. So you can see the PASM code comes out commented with the instructions and the addresses there. It's kind of useful. Sorry, bit of a digression there.
Eric, maybe you can clarify something I'm just chatting with Roy about, which is the interaction between C and SPIN2.
Mhm.
And C only has the ability to receive a single parameter back from a SPIN2 object. But could you write the SPIN2 objects to fully interact with C? Where you ask it for one value and it returns it, and then the next one and so on? Or how could that be managed better?
You could, I think you could declare a structure in C. That's certainly logically in C. Let's close some of these. If you declare a little structure like struct multival, and then you could do something like, oh, that's Z. You do something like Z equals spin object dot multi, however that works. So this spin object would then return Z dot A, you know, printf, and Z dot B. Does that make sense? So in the spin code, it would be something like pub multi So if the spin code looked like this, where this isn't going to be executable, of course, but if the spin code was returning the two values A and B, in C you would probably declare it as a struct and get it back, and then individually use the pieces of the structure. I haven't tested this yet, though. That's my theory of how it would work, because in C, if I wrote this in C, I would write something like struct multival multi int x int y, and returned a small structure like this. It would return it in registers just the same way that spin returns multiple return values. So that's the theory anyway. That isn't as well tested as anything else. That's still cutting edge.
Well, I see Roy nodding his head up and down, so that's a positive thing. I'm just thinking ahead too, when Chip starts writing more objects for us, like some of the video objects, which I really want, and things get easier for people to use, how we can support this interoperability between languages without having people rewrite SPIN2 objects in C.
Yeah, well, like I say, you know, we can generally just dim class using, or in C you'd use the struct using, and multiple return values are a little bit of a pain right now. And maybe we'll be able to figure out an easier way to deal with those later. But for single return values, you just use them the same way you do the spin objects. You use them from C the same way you would use them from spin2.
So would there be any particular language that would be the best choice for writing objects?
Whatever one you're most comfortable in. Well, for writing low-level device objects, I mean, spin2 is kind of the official language. That's what Parallax is supporting. And that's the one that will get you the biggest audience. You know, people will be able to use spin2 objects in any projects. So for sharing things widely, spin2 is probably the first choice. But for your own projects or for, you know, niche kinds of things, just pick whatever is most comfortable. You know, if you've already got some C code that drives this device, write it in C, and then you can use it as an object, or just link directly to it. And of course, like, I mean, this example shows BASIC using SPIN2 and C, but all the combinations work. SPIN2 can use C and BASIC, and C can use BASIC, you know, any combination.
To take some more questions for Eric.
Hey Eric, this is Ray here. I was wondering about using, I saw IMU code, you know, for like a 9° of freedom type sensor. It seems to be always in C. I was wondering how likely that is to work under FastSpin.
I hope it would work. If it's fairly straightforward C, you know, C99, so it's not using C++ features or really recent C extensions, I think there's a good chance. There's still bugs in FastSpin, so you may run into one. I can't offer any guarantees.
All right, thank you.
But
Eric,
if you do have a problem, let me know.
Have you mentioned earlier having more elbow room in the P2, of course, for programs. Have you done any testing or checking on, say, some of the examples that you showed us, how much space they take and how much extra room you have left over?
Well, okay, the turtle demo, let's just quickly, oh, I don't want to. That's a pretty big demo because it's using, that's 200K. That includes the frame buffer, which is 320 by 240 by 16-bit per pixel. So, you know, that's using less than half, and most of that is the frame buffer. So you can always look and see down on the bottom here, the compiler output window. It'll always print what the program size is, and that's the total program, including all the data and storage space needed.
So in order for, Eric, this is Jim, for the program to know, for FlexGUI to know what language you're using, that all comes about at the point where you save the file. Is that right?
It's based solely on the file extension. So
Okay.
if you call it turtledemo.bas, that's a basic. And if it's .spin2, it's a spin2. If it's just .spin, it's spin1.
Yeah, what you completely left out is that Python stuff you did also. MicroPython, also callable from FlexGUI.
Well, that's kind of a separate. Yeah, on the special menu there is a you can run MicroPython, but it's kind of, that lives in its own separate world. There's also a Lisp. One of the demos here is a C version of the Lisp language, which you can run on the P2. But again, they're kind of separate worlds unto themselves. They don't interact with the compiled code. So I didn't want to muddy the waters.
This has been very useful, Eric. Another question, I think?
Sure, go ahead.
Okay, okay, I have one. How you do that with your time?
I wish I had more time. There's never enough hours in the day.
I imagine you have 1,000 hours into this or more.
Yes. Yeah, this has been developed. This all grew out of the program called Spin to CPP, which you may remember from the P1 days, and that's been going, I don't know, since 2012, 8 years. And that still exists, by the way. I mean, you can still convert, if you want to, you can convert these Spin 2 programs into C for use with other compilers. That's probably bit rotted a little bit at this point because since FastSpin can directly use the C, I haven't been testing the C output as much, but
So I could write a mixed language program with FlexGUI, create C and run it over the MicroPython GCC compiler, the ARM GCC compiler.
You can, yes. I have used like some video demos. I have compiled with the RISC-V emulator after converting them from Spin 2.
All the more reason to go to Patreon and support Eric.
Well, thank you. It certainly helps. I mean, the more, you know, I would love to be able to do this full time. Obviously, right now, we're nowhere near that position because there's simply not enough P2s in the world. But
Ken is working on that.
Ken's working on that, and I'm sure
Trying hard, yeah.
We'd all like to see the P2 take over a huge chunk of the market.
Well, it's pretty clear we're still in the early phase, and I think that things have to get easier to achieve. Many people I've seen asking about the P2 or asking me what it can do, and everything is not a good answer. So some clarity will emerge pretty soon, and I'm looking forward to that. And as far as FlexGUI, Jeff and Chip and I from Parallax are all watching this, and we definitely want this to succeed. We need this thing to win out there. We just don't know exactly how we could fit it in without taking calls on it, you know, and it has to be coupled to revenue we get so that we could support you. And then these are all tricky things. And I don't suppose you'd ever leave us with the code base and walk away, but those are the kinds of things we have to look out for. But we see very clearly the Windows, Mac, Linux, the C integration. These are some big things that we don't have that we need to matter to a lot of people.
And then I have another question just to put more on your shoulders. How about some compact memory model or even extended memory? Was it hyper?
Well, maybe someday. But I think I want to get everything stable and working well in Hub first, and then we can look at other things.
Well, great. I'm going to put the link to Patreon one more time in here. So go there and leave some money like we have today. It's all been free for us. Eric, you've done an amazing job so far. And I've seen some improvements even from when you showed it to Jeff, Chip, and I 2 months ago.
Thank you. Thank you. And I should warn everyone, I mean, Patreon is a recurring thing. If you just want to make a one-time donation, I do have a PayPal, and the link is in my signature on the forums.
It's really good. I just found that out.
Yeah, I don't want people to get charged every month for some large amount.
Yeah, Eric, I wanted to say thank you for creating this, because it has been my tool that I've used to learn about the P2 and develop for the P2, and it made it very easy for me to be able to take code I'd written for the P1 and bring it to the P2. And I am I am on Patreon, and every month I am very happy to give you a little bit of money and just give you a little bit of thank you, because it's a fine piece of software you built here. I mean, out of the gate, it's been very nice.
Thank you very much. No, I appreciate that. And that's certainly the goal. I wanted to have something that would let us quickly get stuff up from our P1 code and get it running on the P2. And I'm glad it's working.
Nicely put, Terry. I've seen you using it on other social media too, sharing the P2 with other people. Thanks for doing that.
I too have loved the integration with Python. It opened my eyes to Python now too.
Yeah, that's a whole other topic, which I guess I think the Oz people will be talking about. But
yeah, as time goes on, niches will be more clearly defined, but we're going to see a pretty interesting P2 Python presentation in a couple weeks, hopefully, that uses Mu, an editor for Python. But it's facing some similar challenges with using spin objects, but it looks like they can be overcome as well.
Hey, where's Chip? He's on. Why doesn't he chime in?
Did you get that, Eric? His audio was broken up.
I didn't get that.
No, I was just saying that Chip is signed on, but he hasn't chimed in yet.
Chip hasn't chimed in?
Oh, yeah,
Well,
yeah. Yeah, and Chip is here.
Oh, that's great. I mean, Chip's done a nice job. The Spin2 language is really clean. It's a nice design, and I think I'll certainly keep trying to make FastSpin more and more compatible with it.
I have a question too for the audience. I'm curious if anybody is involved right now in any product designs using FlexGUI, for example, since it's been the main tool. Maybe you could just tell us with your thumbs up or leave a comment if anybody's making any product related design efforts. Okay, cool. I'll have my salespeople contact you right away.
I sent you an email on
Yeah. Yeah, that's good. And we want to know about those products that people are making. And it doesn't mean we're going to share them or we're going to ask you to buy chips. We just need to start learning more.
Hey, Erica, just out of curiosity, do you think FastSpin could compile the C that Blockly prop makes?
Well, once the libraries are ported, and Roy's been working on that, I think so. I haven't tried it though, because the libraries aren't all there yet. So it's.
That would be quite the tool stacker to achieve that.
Yes.
Great. Okay. If there are no more questions, we will wrap up. Thank you again, Eric.
Well, thank you. Thanks for everyone for your support and for any kinds of feedback. If you have any problems, please let me know. And bug reports always help to improve the tool. So.
Eric, thank you very much for your contribution.
Thank you, Eric. I enjoyed that very much.
Oh, thank you. My pleasure. Thanks, everyone.
Wonderful. Well, you can enjoy the rest of Canada Day now with Bob.
Thank you. We will.
See you on the forums.
See
Bye.
you guys.
Happy
Bye.
4th of July, everyone.